Now that we've talked about factoring and we saw that we can use factoring as a means to solve equations, we now move on to another area that of algebra where factoring has a particular use. And that's in the area of working with rational or fractional expressions. Now we begin kind of introducing things. One of the things that we can talk about with rational expressions is to evaluate an expression. Remember, that's kind of the basic low-level algebra where we're just taking variables and replacing them with numerical values. So to kind of get back into the flow of rational expressions, let's begin with that kind of example. And so we evaluate, so we might say let's evaluate that when x is 2. So remember, to evaluate an algebraic expression, all we have to do is take and replace the variable with that number. And so we go ahead and do that. Replace the x with 2. And we get 2 times 2 plus 8 over 2 minus 3. And we just do the simplifying. Numerator simplifies to be 12. Denominator simplifies to be negative 1. We have 12 over negative 1, which would become negative 12. Okay, so that's just our first example. We can evaluate for any number we want, or at least we think we can. We'll find out in a moment that we can't, but for now let's go with the idea that we can plug any number in we want. So let's consider x equals negative 4. If we plug negative 4 in, we'll get 2 times negative 4 plus 8 over negative 4 minus 3. Numerator becomes 0, the denominator becomes negative 7. 0 divided by negative 7 is 0. Okay, and now we move forward to our third example, where we want to plug x equals 3 into that fractional expression. And so we go ahead and do that. We get 2 times 3 plus 8 in the top, 3 minus 3 in the bottom. The top simplifies to be 14. The bottom simplifies to be 0, and then we say, okay, we got to simplify that, but oh no, we got a problem. All right, the denominator is 0, and we can't divide by 0. All right, we can't do it because we say that's undefined. So that expression there, 14 over 0, is undefined, which means that that algebraic expression, 2x plus 8 over x minus 3, is going to be undefined when x is equal to 3, and it's undefined because x equals 3 makes that denominator 0. Okay, this brings us to our first real thing that we want to talk about now with rational expressions, and that is finding out what values make the denominator or make the rational expression undefined. And as we saw in this illustration here, anything that causes the denominator to be 0 will make it undefined. So now we're asked here to find any the expressions that are going to be given to us are undefined. Any values for which those expressions are undefined. Okay, so for our first example, we have the expression 3 over 5x, and we'd like to know when that's undefined. Well, based on what we've just discussed, if the denominator is 0, then it's undefined. And in fact, for these fractional expressions that we're going to be dealing with, if it's undefined, then the denominator is 0. And so it goes both ways. Denominator 0 makes it undefined. Being undefined for these fractional expressions means that the denominator must have been 0. So we need to find out when is the denominator of this thing equal to 0. So we set the denominator equal to 0 and then solve that equation. And solving that equation, we find out a value of 0 would make the denominator 0, and so therefore a value of 0 would make the rational expression there, 3 over 5x, undefined. Okay, consider our next example. 2x plus 1 over 3x plus 5. 2x plus 1 over 3x plus 5. We'd like to know when is this undefined. So based on the same thing we did in the last example, take that denominator, set it equal to 0. And then proceed to solve that equation. Again, I encourage you as you're doing these problems in the videos, pause it if you feel comfortable and try to go on without me doing it for you, that you can start practicing it. So solve that equation, we get x has to be a negative 5/3. Okay, one more example of answering the question, for what values is the expression undefined? Consider the expression x minus 5 over x squared minus 4x minus 12. The numerator doesn't contribute to being undefined. Again, we only look at the denominator. So we set that denominator equal to 0. And notice now we have a second degree polynomial equation. And so now I would ask you to take a moment and try to factor it. Here we factor because things that multiply to be negative 12, add to be negative 4 would be a negative 6 and a positive 2. And again, once we've factored it, we can set each of our factors equal to 0 and then solve each of those individual equations. And so we find out there's actually two values that this expression is undefined for. Those would be x equals 6 and x equals negative 2. Okay, so from here we're going to move on now to simplifying algebraic expressions, and we'll be doing that in the next video.